Hello, good morning all. Today we want to see the chapter electrophilic addition to carbon-carbon double bond and carbon-carbon triple bonds. Here we are going to see the first part, that is the electrophilic addition to the carbon-carbon double bonds. Before going to start this topic, some terms we should know about the electrophilic addition reactions. In that, first one is the what is electrophile, what is the addition reaction, and what is the carbon-carbon double bonds. So electrophile is the any species which is having electron deficiency. It can be ionic, or it can be partial positive charge on the species. Then we want to see what is addition. Addition, it means two atoms or molecules are added across the carbon-carbon double bond. Such a reaction is called as addition reaction. And the carbon-carbon double bond and carbon-carbon triple bonds. In electrophilic addition reaction, why it is called as electrophilic addition reaction? Because first electrophile is added across the carbon-carbon double bond. Therefore, such reactions are called as electrophilic addition reactions. Here we want to see some examples for that. Okay, so this is a simple reaction. The first one is the substrate which is having carbon-carbon double bond CH3 CH double bond CH2 plus HBr, and it will give CH3 CHBr CH3 is the product. What happens in that reaction? That hydrogen and bromine are added across this carbon-carbon double bond, and therefore first hydrogen is added in that reaction, and therefore such a reaction is called as electrophilic addition reaction. We have to see the mechanism for this. As we know that carbon-carbon double bond having pi bonds, and because of that the electron density around that carbon-carbon double bond is the higher. Therefore, it can act as a nucleophile because it is a rich in electron, and when it reacts with HBr, that hydrogen is having partial positive charge and bromine is having partial negative charge because of the electronegativity difference between hydrogen and bromine. So hydrogen is slightly electron deficient, and that carbon-carbon double bond is electron rich species. So that carbon-carbon double bond can give its electron to that hydrogen and form a bond between carbon and hydrogen. At the same time, the bond between hydrogen and bromine has been break down, and it will forms a Br minus. So I will write here CH3CH plus CH3 plus Br minus. So in that step, first carbocation is generated on the substrate, and that bromine having negative charge because as it has 2 electrons extra. In the next step, that CH3 CH plus CH3 reacts with Br minus, and that Br minus gives its electron to that carbocation to form a bond between carbon and bromine, and it will form a new structure, that is CH3 CH and CH3. So such kind of the reactions are called as electrophilic addition reactions, because first hydrogen is added. Hydrogen is electrophile, and therefore it is firstly added in that across the carbon-carbon double bond. Therefore it is called as the electrophilic addition reaction. We can see that that hydrogen is added on the terminal carbon in that reaction, but there is another possibility that carbon may be added on the middle carbon, and that carbocation is generated on the terminal carbon. So what happened in that case? So in that case we got a different carbocation, that is CH3CH2 CH2 plus. Now you can compare both carbocations CH3CH plus and CH3. In that both carbocations, first one is the terminal carbocation CH2 plus, and in second case it is the CH plus, it is the middle carbocation. What happened because of that? First carbocation is less stable because it is a primary carbocation. As we know that primary and secondary carbocations, and therefore second carbocation is the secondary carbocation, as that carbon having two carbon adjacent to it, therefore it is a secondary carbocation. And in case first, there is only one CH2 group attached to that CH2, therefore it is called as a primary carbocation. As we know that because of the plus I effect, that plus ion hyperconjugative effect, that secondary carbocation is a more stable carbocation as compared to the primary carbocation, and therefore generation of that secondary carbocation is more favorable and more stable carbocation. Therefore formation of the product we have seen in the first reaction, that is a major product. So how that product is decided, which carbocation is generated? It is depend upon, or it is stated by the anti-Markoving cause. So what is the anti-Markoving cause rule for the addition reaction? We want to see here. First we want to see the Markoving cause rule. So Markoving cause rule stated that in an addition reaction, the negative part of the reagent goes to the carbon which is having less number of hydrogen. What is Markoving cause rule? Again I will explain. In an addition reaction, the negative part of the reagent goes to the carbon which bears less number of hydrogen. For example, again same example we are going to see here. CH3 CH double bond CH2 plus HBr. In that reaction, we want to see here which carbon is having a less number of hydrogen. Here the middle carbon is having less number of hydrogen. In the second carbon in carbon double bond, it is having two hydrogens, and middle carbon is having one hydrogen. So according to Markoving cause rule, that negative part of the reagent, that means bromine is the negative part of the reagent, it goes to the carbon which is having less number of hydrogen. That means the carbon having only one carbon, that is the middle carbon. That means the hydrogen is added to the CH2, added on CH2, while that bromine is added on the CH. And why? Because as we explained, the generation of the carbocation in that step, it is a secondary carbocation which is the most stable, and therefore it is a favorable mechanism for the formation of that Markoving cause rule. Okay, so as per that, we want to see the again same product, that is CH3 CH Br and CH3. The another possibility is that it will form another compound, that is CH3 CH2 CH2 and Br. Okay, in that cases we got 2 bromopropane as a major product, while that 1 bromopropane, it is a minor product as per the Markoving cause rule for the addition reaction. So this is about the Markoving cause rule for addition reaction. Then we want to see the anti-Markoving cause rule for the addition reaction. This anti-Markoving cause rule, it is exactly opposite to the Markoving cause rule. In case of the anti-Markoving cause rule, as per the anti-Markoving cause rule, the negative part of the reagent goes to the carbon which is having more number of hydrogens. That means we got the two products, one is the major and another one is the minor. For example, CH3 CH double bond CH2, same example, and when it reacts with HBr, again it will give two products. One is the CS3 CH CS3 and Br, and another one is CS3 CH2 CH2 Br. In case of the anti-Markov-Cause rule, all conditions are same, but in presence of BHBr we have to use hydrogen peroxide, and because of that we got two products, two bromopropane as well as one bromopropane. In this anti-Markov-Cause rule, the two bromopropane is obtained as a minor product, while that one bromopropane is obtained as a major product. It is exactly opposite to the Markov-Cause addition rule, and therefore we got different products, that is two bromopropane as a minor while one bromopropane as a major product. We have to see here some addition reaction, electrophilic addition reaction examples. The first example of electrophilic addition reaction is hydrogenation. Hydrogenation reaction means addition of the hydrogen across the carbon-carbon double bond. For example, when we are having H2 in presence of any metal like palladium or nickel, that hydrogen is added across this carbon-carbon double bond, and we got that addition of two hydrogen, and therefore such reactions are called as hydrogenation reaction. Another example of the addition reaction is hydrohalogenation. In hydrohalogenation reaction, one hydrogen and one halogen is added across the carbon-carbon double bond. Therefore, such reactions are called as hydrohalogenation reaction. For example, CS3 CH double bond CH2 plus HCl. Here we got addition of hydrogen and chlorine across the carbon-carbon double bond. Therefore, such reactions are known as hydrohalogenation reaction. Another example of the addition reaction is halogenation reaction. In halogenation reaction, there are two halogens are added across the carbon-carbon double bond. For example, CS3 CH double bond CH2 plus Br2. So that bromine atoms are added across the carbon-carbon double bond. So we got CS3 CHBr and CH2Br. Both halogen atoms are added across the carbon-carbon double bond. Therefore, such reactions are called as halogenation reactions. Another example of that addition reactions are hydration reaction. In the hydration reaction, water molecule is added across the carbon-carbon double bond. Therefore, such reactions are called as hydration reaction. So here we got 2-propanol, 2-hydroxypropanol as a addition product, because the hydrogen and OH are added across the carbon-carbon double bond. Therefore, such reactions are called as hydration reaction. Another example of that addition reaction is hydroboration. In case of the hydroboration reaction, hydrogen and boron atom is added across the carbon-carbon double bond. Therefore, such reactions are called as hydroboration reaction. For example, when that alkene reacts with the BH3, one of the hydrogen from boron atom has been added across the carbon-carbon double bond, and it gives CS3, CH2, CH2 and BH2. So this, in that reaction, hydrogen as well as boron both are added across this carbon-carbon double bond, and therefore such reactions are called as hydroboration reactions. Another examples are also there, like ozonolysis, that is addition of ozone molecule, and many more. So we will stop here. Another part of that topic we want to see in the next lecture. Thank you.